So an ellipse with an eccentricity of 0.65 and one of its foci is 2 units from the center. The length of the latus rectum is nearest to. Now, so how will we deal with our latus rectum? Okay, so let's try to solve this. Right? Okay. Okay. So we have 2 units from the center. So our foci, 2 units from the center. 1, 2. So our foci is our letter C, right? So which is 2 units from the center, therefore we have positive, negative C. This is 1, 2, negative 1, 2. At center 0, 0. Its eccentricity is equal to 0.65. So 0.65 is equal to E, which is E is equal to our C over A. So we have 0.65 is equal to 2 all over A. So therefore A is equal to 2 all over 0.65, which will yield to 3.071 or 3.08. Okay. 3.077 lang. Okay, so we have 3.077. Now, what is our latus rectum? Our latus rectum is a chord that will pass through our focus. So therefore, this is our latus rectum. Now, how will we solve this? Take note that there are 2 points in our latus rectum. And of course, let's have my foci too. Okay, so my foci is at, let's say, negative 2, 0, and my other foci is at positive 2, 0, and letting this let's say we don't know the formula for our latus rectum, so therefore we will solve this, or we will derive this. Let's say from my point focus to this point is our LR over 2, but we don't know it yet. So therefore, by creating because locus is, because our ellipse or any point in our ellipse can be solved by adding our, let's say this will be our negative focus and our positive focus. So at any point we have negative f to that particular point plus positive f to that point, or the length of that negative f to p and the length of that positive f p to any point within our ellipse is equal to our constant, which is equal to our 2a, right? So therefore easily we can derive our equation. Let's say at this point P is of course from to a point 2, of course x, right, to an unknown point y. Okay, now from this we can derive our answer, or our equation of our latus rectum, So if I will create another line connecting this to that, and of course my line PF prime, so you would notice that if you would get a distance, let this be our negative FP, and let this be our positive FP. So if you would get their distance, take note that this is our C negative C0 and this is our positive C0, and this will be our CY. Okay, I will just derive it first using our variables only. Okay, so our FP is of course equal to the square root of our C plus C, so minus negative C square plus 0 minus Y square plus my FP is just equal to square root of distance. This is the distance, right? So we have C minus C square plus Y minus 0 square is equal to our 2A. Now from here I will have negative C minus C, we'll have C, 2C, right? So we have 2C square plus negative Y square. So we have positive Y square plus our C minus C is 0. So therefore I will have a value equal to Y square, which is equal to 2A. So I will just derivation for latus rectum. Okay, so from this we can have square root of 4C square plus Y square is equal to square root of Y square is Y, and then I will transpose it to the other side, so 2A minus Y. Again, in order to eradicate for the square root, so I will just square this both sides. So I will have a value equal to 4C square plus Y square is equal to 4A square minus 4AY plus Y square. By further manipulation of the equation, you will notice that we will cancel out our Y square because Y square minus Y square will be equal to 0. And then you can factor out our 4, so therefore 4 divided by 4 is equal to 1. So we'll have C square is equal to A square minus AY. So from here I will have AY is equal to A square minus C square. And we all know that our A square is equal to B square plus C square. So A square minus C square is equal to our B square, right? So from here I will have AY is equal to B square and Y is equal to B squared all over A. Now our Y is considerably the other half of our latus rectum. By our reflection property, if we would consider this whole length, so therefore we will multiply it by 2. So latus rectum LR is equal to 2Y, which is equal to 2 multiplied by B squared all over A. But what is our B square? Okay, our B square can be solved by A square minus C square, which can be directly found in our equation earlier. Okay, so from here I will have LR based on our example. So I have LR is equal to 2 multiplied by B square all over A, wherein we have 2 multiplied by A square minus C square all over A. So we have 2 multiplied by our A, which is equal to 3.077 square minus my C, which is equal to 2 square all over 3.077. So we have an answer for our latus rectum, such as 2 multiplied by 3.077 square minus 2 square divided by 3.077. We have an answer equal to 3.55 for our latus rectum. That is 3.55 units. Okay, so therefore the formula for our latus rectum was derived as LR is equal to 2B square all over A for ellipse.